everyone. What we're going to be doing today is sector arc length and sector area. So all that sector means is just a portion of your circle. Okay, so here, this is a sector of my circle. Same thing here. This is a part of my circle, so it's just a sector of my circle. If we're looking at the entire circle, the area would be pi r squared. So let's say this was like had a radius of 4. Then our area for the whole circle would be pi times 4 squared. Same thing with the circumference. So if the circumference had a radius of 4, then we would just do 2 pi times 4. Okay, 2 pi times 4. But let's say we're looking at a portion of the circle. So the circumference of this entire circle would be 2 pi 4. But what if we're only looking at a fourth of my circle? So notice I'm looking at 90 degrees out of 360. Well, if I'm looking at 90 degrees out of 360 total, then all you need to do is multiply this thing by 90 over 360. Okay, so that's how you would define the portion of the arc length. So you just multiply this fraction by the entire thing. Okay, and the same thing with the area. So the area of this whole circle would be pi 4 squared. But now, if I'm looking at only a fourth of this, then I'm just going to take this area and multiply it by 1/4, which really we're looking at 90 degrees out of the 360 degrees total. Okay, and this would be multiplied by pi 4 squared. Okay, so what this formula really is your regular, we're going to call this L. This is arc length. Usually you're used to seeing C, which means circumference, but this is going to be arc length now. So the circumference formula that we know is 2 pi r. But now what we said is that we're going to have a fraction, which is going to be the degrees that we're looking at. So if I'm looking at 90 degrees, then I'm going to put that on top. So the degrees. And this is going to be divided by the total degrees of a circle. So divided by 360 degrees. Okay, so this is your arc length formula here. This is your arc length formula. And all we're going to be doing is plugging into this formula as we go along. Right? So this is your big formula that we're looking at for arc length. All right, the next formula that we're going to look at is the area of the sector. And it's going to be the exact same process. So the area formula we know is pi r squared. And all we're going to do is take whatever that number is and multiply it by what portion of the circle are you looking at. So are you looking at 90 degrees out of 360? Are you looking at 10 degrees out of 360? That's what you would write here. So degrees divided by 360. So this is going to be your area of a sector. What a sector means is just the portion of the circle. Okay, area of the sector. All right, so what we're going to do now is just a couple examples so you can see how this formula is going to work. So in the first example, it's asking for the arc length of Km. So it's asking for this length right here. This is different than asking for what the degrees of the arc is. A lot of people like to get that confused, but we're just talking about how long is this arc, not asking what are the degrees of that arc. Okay, so we're looking at actual length measures here. So if we know that the measure of KLM, so that's this right here, is 74, and we know that KL is 5, so that's this radius right here, then find the arc length of Km. Okay, so all that we're going to do is we're going to take our degrees, which is this, the measure of KLM, so 74, divided by 360. Okay, so that's what portion of the circle I'm looking at. I'm looking at 74 out of 360. So this is the sector I'm looking at right here. And then I'm just going to multiply this by the circumference formula. So times 2 pi, and then times r, which we just found that our radius is 5. Okay? And then all I'm going to do to calculate this is just put it straight into Desmos. Okay, so I'm going to go to Desmos since Desmos is a calculator. All right, so let me go to Desmos. And I'm just going to type in 74 divided by 360 times 2 times pi, and then times 5. And it's taking its sweet time, but that's okay. All right, so we're going to type in 74 divided by 360, and then we're going to do times 2 times pi, and you can actually type in pi. Wait, not if you have cap locks. Pi, and then times the radius, which is 5. Okay, so the answer here is 6.4577, but in Delta Math, it's going to ask you to round to the nearest hundredth, or it's asking in this case, so that's 2 decimal places, so we're going to do 6.46, okay, because that's 7 rounds to 5 up, so 6.46. Yeah, 6.46. Okay, so that is your arc length here. We're going to do another example using this formula, and then we're going to move on to area. So this one, find the arc length of SU, so that's asking for this, if the measure of STU is 82, and the measure of ST is 20 degrees, or is 20, sorry, not 20 degrees. Okay, so we're just going to plug this straight into the formula. It's always the measure of the angle, so 82, divided by 360, and then times the circumference formula, so times 2, times pi, and then times the radius, so times 20. We're just going to type this guy straight into Desmos so it'll calculate it for us. And I actually already have the setup, so all I'm going to do is change this to 82. And then I'm going to change this 5 to 20. Okay, so this is going to be 28.62. 28.62. All right, now I'm going to do some examples with the area, right, with the area. So let's move on down to the bottom. This is a very similar process, except you're using a slightly different formula. So, looking here, find the area of sector QRS. So it's asking for you to find this area here. If the measure of angle QRS, so that's this, is 134, and the radius is 6, QR is 6. Okay, so what we're going to do, same thing that we did before. We're looking at 134 degrees out of the total 360. But we're trying to find the area, so we're trying to find pi r squared, so 6 squared. And then we're just going to type this guy straight into Desmos and let it do its work. Okay, so I'm going to delete this 2. And then I'm going to change this to 134. I'm going to change this to 6 squared. Okay, and there's your answer, 42.097. Okay, 42.097. Since we're doing it to the nearest hundredth, that 7 is going to round that 9 up to a 10. So then that's going to have to round up, so it's just going to be 42.10. 42.10. Okay, we're going to do one more area problem, and then that will be it for your notes today. So let's go on to the fourth example. Find the area of sector BCD, so it's asking for this area. if the measure of angle BCD, so this, is 66, and the measure of BC is 15. Okay, so we're going to do the exact same thing, plug it into this formula. We're looking at 66 degrees out of the total 360 in a circle, but we're looking at the area, so it's going to be times pi 15 squared, pi r squared. So again, I'm just going to type this straight into Desmos since it is a calculator and figure this out. So I'm going to type in 66 divided by 360 and then change this 16 to a 15. And there's our answer. So it's going to be 129.59, and the 0 doesn't do anything, so it's just going to be 129.59. Okay, so let me show you what this looks like in Desmos, and then you'll be all set. Sorry, in Delta Math, not Desmos. In Delta Math, it's just going to have an arc length section and it's going to have an area section. So let me show you an example of a problem like this. Okay, it's going to be the exact same thing that we just did. So let me just show you the solution here so you can see what Delta Math will tell you. The exact same thing that we were just talking about. So it's going to be your degrees out of 360 and then times the circumference formula. So here we're looking at 124 degrees out of 360 and then times 2 pi and then the radius. Again, this is to the nearest hundredth. Please make sure you check that you're rounding to the right place. And then in the area of the sector one, I actually just did this problem with you. So where the central angle is 66 and BC was 15. So let me just show you what Delta Math will show you. And it's the exact same thing that we just did. So we get 129.59. Okay, that's all that I have for you today. Hopefully you enjoyed this video and it doesn't take you too long to do your assignment. Enjoy the rest of your day. Bye.